Penuh kesungguhan Akademi Youtuber Malaysia Rangka laksana dengan jitu Penuh bervisi Guru AYU Mencapai misi yang satu Permisi kita bantu
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Indah berbalam si pohon ara berbalam di peti celah. Indah berbalam si awan petang berarak di celah pepohon ara. Pemanis kalam selamat datang awal bismillah pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Selamat petang dan selamat datang ke kelas tuisyen online percuma yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-Didik Malaysia. Bermula percuma, selamanya percuma. Jadi insyaAllah pada malam ini kita akan ikuti satu lagi kelas fizik untuk tingkatan 4 dengan tajuk yang seterusnya 3.2 Kepler'S bersama dengan saya Cikgu Hasnitah dari SMK Bagan Jaya. Jadi sebelum kita memulakan kelas pada malam ini, ayo kita mulakan dengan umul kitab Al-Fatihah, dan bagi yang bukan beragama Islam, anda boleh bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Bismillah. Amin, amin, amin ya Rabbal Alamin. Jadi adik-adik yang sedang mengikuti kelas ini, boleh anda respon kepada cikgu kalau anda boleh dengar saya dengan jelas. Boleh type dekat live chat jelas, boleh type clear teacher, okay? Sebab dan kita tengok siapa yang ada bersama dengan kita. Kita ada Ciaying di sana. Ya, cikgu baik. Kabar baik Ciaying. Alhamdulillah cikgu sihat. Kita juga ada Jimmy di sana. Jimmy Ken. Dan kita ada siapa lagi di sana? Yo Kawi. Okey, kita juga ada Kai Roheng bersama dengan kita pada malam ini. Okay, thank you very much Jimmy for your respon. Yang lain pun boleh beri respon kepada Cikgu Hasnitah. Kemudian anda boleh lihat pada pin message di sana. Cikgu ada sertakan nota dan latihan untuk bab ini 3.2 Kepler'S Law. Anda boleh klik pada link tersebut. Boleh muat turun dan cetak keluar nota yang cikgu sediakan secara percuma sahaja. Pautan ini juga boleh anda peroleh pada bahagian deskripsi video di bawah ini. Jadi cikgu harap penerangan pada malam ini akan membantu anda untuk faham tajuk ini dengan lebih baik, dan bahan yang cikgu sertakan bolehlah anda jadikan sebagai nota tambahan selain daripada bahan-bahan yang diberikan oleh cikgu anda di sekolah masing-masing. Okey. Kita juga ada Prabu di sana, Prabu Pirabaga. May I know where are you from? Yang baru saja mengikuti kelas ini, boleh anda bagi tahu anda dari sekolah mana? Contohnya SMK Bagan Jaya, Pulau Pinang. Alright. Dan di sekolah anda sekarang belajar di topik mana? In which topic you are learning now in your school on Physics Form 4? Alright. Okay. Okay, so without further ado, tanpa melengahkan masa lagi, mari kita mulakan. Tapi sebelum itu cikgu nak ingatkan, di akhir kelas ini nanti cikgu akan kongsikan pautan pada sijil E, sijil Express. Anda boleh isikan nama dan nombor kad pengenalan, dan sijil itu akan dihantar ke dalam email yang anda gunakan dalam kurang daripada 10 saat saja. So anda boleh dapat terus sijil untuk kelas malam ini. Begitulah dengan sistem sijil e-express yang kita gunakan di tuisyen online percuma Akademi Youtuber. Okey, jadi tanpa membuang masa, cikgu mulakanlah. Okay, let us begin our lesson tonight with Physics Form 4. This is Chapter 3, Gravitation, on Content Standard 3.2, Kepler's Laws. Alright? Okay, so in your textbook, students, you can find this lesson on page 96 till 102. It's a short chapter and not so difficult to understand. Alright? Okay. We also have NH Han there. Okay, hi Han. Okay, hope you are doing well. So everyone, if you are ready and good to go, let me introduce to you first all the physics team members in Akademi Youtuber. In physics panel, we have there, you can see Cikgu Izyan, we have teacher Rina, Rashid, Cikgu Syuhada, we have Mr. Pek Kok Hua, and Cikgu Kok also there, teacher Slinda Nordin, Cikgu Hendon, and Cikgu Rosemawati. Actually, we have a few more, and me, Cikgu Hasnitah, as the head panel of physics department in Akademi Youtuber Malaysia. Okay, so in this second slide, you will see this is one application you can download in your Android. Ini adalah satu aplikasi yang anda boleh muat turun pada Android anda on your handphone. The apps is called Akademi Youtuber apps. Okay, apa yang ada dalam apps ini? Kita ada 20 lebih daripada 28,000 video PDP. Itu jumlah yang terkini untuk subjek-subjek daripada prasekolah hinggalah ke pra-universiti. Jadi anda boleh lihat video-video dalam apps ini dan seharapnya video ini dapat membantu anda untuk mengulang kaji dan memahami sesuatu topik itu dengan lebih baik. Okay, video-video ini telah dihasilkan oleh guru-guru sukarelawan Akademi Youtuber dari seluruh Malaysia. Alright, kita juga ada Tiva di sana. Tiva taruh sini. Thank you for joining us tonight, Tiva, and hope you can share the link for these classes to all of your friends so more can benefit from this session. Okay, kita akan berjalan kelas kita lebih kurang 1 jam. Alright, and as I mentioned earlier, you will be rewarded with the e-cert at the end of this lesson. Okay, students, so let us take a look at the first learning standard. So actually in 3.2, we have 3 learning standard. So the first one is to explain Kepler's laws, right? So what is Kepler's laws? So this is the physicist, okay, a German physicist called Johannes Kepler, who introduced Kepler's laws. All right, and we have 3 Kepler's law altogether. So the first law, okay, for those who have learned this in school, you can respond to me. What do you understand on Kepler's first law? All right, or those who have finished SPM and still following this session, you can also give some response. What do you remember about Kepler's law? Yes. Alright, so according to the textbook, so Kepler's first law, it mentioned or it states that all planets, okay, all planets in the solar system is moving in elliptical orbits. Okay, all planets move in elliptical orbits where the sun lies at one of its focus. Okay, and student, Kepler first law, also called as law of orbits. It's also known as law of orbits, right? So this is the elliptical shape. Okay, for elliptical shape, as you learn in mathematics, elliptical shape has 2 focus point. Okay, and sun is positioned at one of these focus, either the focus on the left or the focus on the right, and this is the planet that orbiting the sun. So again, Kepler's first law is also known as law of orbits. Okay, as you can see in this animation, okay, this is how the planet move along this orbit, and you can see it is moving in a higher linear speed when nearest to the sun and moving with the lowest linear speed when it is furthest from the sun. All right, okay. And there is one activity in your textbook where we can learn, okay, how to sketch the shape of an ellipse based on the concept of dual foci of ellipse. All right, okay, so if you have your textbook, you can scan the QR code there in your textbook. to download the assignment sheets. Okay, and this is all the material required to conduct this activity. All right, you need a pencil, at least 20 centimeter length of thread. We need 2 thumbtacks as well, A4 paper, a softboard, and a telephone tape. If you don't have this thing now, never mind, you can try them later. Okay, this is a DIY project. You can do it yourself later. All right, and this is the instruction given when you scan the QR code there. They give you instruction from number 1 to number 8. Okay, so are you ready to go to sketch the elliptical shape orbit? I will show you one instruction video. So later you can follow sketching this orbit by referring to this video. So this video is according to these instructions given. All right. So ready, students? Okay. Let us look at this video together. So first and foremost, you prepare an A4 paper and fold it. Can you hear the sound from this video, students and teachers? You can respond to me at the live chat. Okay. Can you hear the sound from these demonstration videos on how to sketch the elliptical shape orbit? Okay. Ciaying boleh dengar tak suara daripada video yang sedang cikgu tayangkan? Tiba Tashinihan. Okay, very good. Thank you for your response. Okay, so I continue in this way as shown in this video. Okay, and then we fold it in another way for twice. Fold for once and fold for twice. Okay, so you are going to have this shape. Then we unfold the A4 paper, and you are going to see there will be 3 points on it. Okay, so this is the first point, second point, and the third point. And what to do next? We place our thumbtacks on the first point, and another one at the third point. Before that, you attach the thumbtacks with a thread for about 20 centimeters. Long. Okay, so we label the first point as F1, our first focus, and the third point as F2, our second focus. Then next, we tighten the thread with a pencil and bring it to the left side of F1, and we start to draw the shape. Make sure when you draw the shape, the thread is always tight. Okay, so we bring our pencil to the right side of F2 along the major axis. So you can see the half of the elliptical shape. Then we continue to complete another half by drawing the shape below the major axis. And next, we can remove the thumbtacks away. Okay, so you can see now this is the we have it. Okay, where we have this is the major axis. This is the minor axis, and this is the center of the elliptical orbit, where this is the two focus F1 and F2. So the next step, you can draw the sun at any one of these two focus, either at F1 or at F2. So I draw our sun, which is the center of the solar system, at F1, and I draw my Earth at any point along the elliptical line. Okay, so we are done with first Kepler. Kepler's first system is an elliptical shape where the sun is at one of its focus. Okay, students, so that is the demonstration video on how to sketch, okay, on how to sketch our elliptical orbit. So how do you find the video? It is It is help. Nak pengsan, kenapa nak pengsan tu Cia Ying? I hope the short video can guide you on how to sketch the elliptical orbit as mentioned in Kepler's first law. Lepas ni boleh practice untuk lakar bentuk elips orbit yang ada dalam solar system mengikut hukum Kepler pertama. Okay, so can you give me some response on the demonstration video, students? What do you think about it? Apa pendapat anda? Alright, and from the video I showed you just now, let us try these three question as our discussion. Okay, the first question very simple. Name the shape of orbit owned by planets in the solar system. Namakan bentuk orbit dalam sistem solar. Okay, name the shape. Apa nama bentuk yang kita lukis tadi, Cia Ying? Alright. Anyone who can respond to this question, name the shape of the orbit owned by planets in the solar system. Alright. So most of the planet in the solar system has an orbit of, yes, ellipse. You can write ellipse or elliptical shape. Ellipse or elliptical shape. Yes. And then the second question, how to describe? Okay, describe how the distance between the Earth and the Sun changes when the Earth makes a complete orbit around the Sun. So how to respond to question 2? Anyone would like to give a try? You can type your thought in the live chat. Alright? Okay. Describe how distance between the Earth and Sun changes when the Earth makes a complete orbit around the Sun. So how to respond to this? You can see that the distance is further at the major axis. The distance of the planet from the Sun will be further when it is at the major axis. The major axis is the horizontal axis and the minor axis is the vertical axis. Yes, very good. Okay, then we have Kavya Sagunan there. Hello Kavya. You just missed the demonstration video, Kavya. I showed just now on how to sketch the elliptical orbit. Never mind, later on you can review back to the first part of this video. Okay, the third discussion, student. How the shape of the Earth orbit will be if the major axis is almost as long as the minor axis. Okay, what do you think about this question? Okay, now what do you think the shape of the Earth if the major axis is almost as long as the minor axis? Kalau paksi major dengan paksi minor tu punyai panjang yang lebih kurang sama, agak-agak apa bentuk orbit bumi? Kalau kita tengok tadi, major axis it has a longer length. Panjangnya lebih panjang daripada minor axis. But what if now they have about the same length? So definitely the shape of the orbit will be almost circle or almost round. Alright? Okay. So this is the conclusion we can make from the first activity on Kepler's first law. Okay, number 1, from activity conducted just now, we understand all planets in the solar system have elliptical shape orbit. Yeah, very good, Jimmy. This is the answer for the third question just now. Okay, thank you for your response. Okay, all planets in the solar system have elliptical shape orbit. Okay, and for the second conclusion, we can say that the sun always stay on a focus of the ellipse. Okay, the sun always stay at one focus of the ellipse. Okay, and third, the major axis is longer than the minor axis. Okay, so this is the third conclusion for Kepler's first law, and we have another 3, number 4 there. We understand most orbits of the planet in the solar system have major axis and minor axis of almost the same length. So we say planets are assumed to make circular motion around the sun. Okay, and last but not least, the radius of orbit is average value, okay, of the distance between the planet and the sun. When we do calculation on the radius of orbit, we consider that the radius of orbit is the same at any position of the planet around the orbit. Either it is at the major axis or at the minor axis. The average radius is about the same. Alright, so I hope you are clear with the sixth conclusion for Kepler's first law of motion. Alright, Kepler's first law. Okay, now let's take a look at the Kepler's second law. The second law. Okay, what does Kepler's second law state? Okay, anyone? If the first law talk about orbit, law of orbit, okay, so Kepler's second law talk about area. So that's why it is also called as a law of area. So Kepler's second law state that a line, if you see the animation there, a line that connect a planet to the sun. So the planet is moving, orbiting the sun. Okay, you draw a line connecting it to the sun. Okay, a line that connect a planet to the sun sweeps out equal areas in equal times. Okay, a line that connect, garis yang menghubungkan planet dengan matahari menyapu kawasan yang sama luas pada masa yang sama. Okay, so that is the definition for this Kepler's second law. A line that connect a planet to the sun sweeps out equal area in equal time. Okay, which means here you can see two sectors. Okay, we have two blue sectors. The first sector on the left, and this is the second sector on the right. Okay, the planet took same time. Okay, to produce this sector. Let's say it moved from this end to this end around 10 seconds. Okay, and on the right sector also, it took 10 seconds to move from this end to the other end. So when you calculate the area will be equal. The area of this sector will be equal to the area on the right sector. So this is meant by Kepler's second law. A line connect a planet to the sun sweeps out equal area in equal time. If here take 10 seconds to produce this sector, here also 10 seconds to produce this sector. Okay, are you clear with Kepler's second law? If you do, you can type 1 on the live chat. Siapa faham Kepler's second law, boleh type nombor 1 dekat live chat. We also have Chan Mei Yi there. Hello Mei Yi. Thank you for being here. We are now studying Kepler's laws. Alright. Okay, now let us see a few more details on Kepler's second law, students. Okay, so this is the next drawing to understand Kepler's second law. Yeah, thank you for your response, Mei and Jimmy. What about the rest? Okay, you can give your response as well. Okay, now student, okay, you see this is our sun at this focus of an elliptical shape orbit, and we have our planet there. Okay, this is our planet at this position, and there is a 4 points marked in this orbit. Point A, point B, produce this sector ABF, and then here we have point C and point D, producing sector CFD. Okay, if you look at these notes, if a planet take the same amount of time to move from A to B, and from C to D, here C to D. So this means the area of AFB is the same with the area of CFD. Okay, so this is the second understanding on Kepler's second law. If planet took, let's say, 20 seconds to move from A to B, it also moved 20 seconds to move from C to D. So this sector will be equal to this sector on the right. Okay? Okay. Very good. Okay, next. Okay, what about this? Okay, so from here we understand distance AB. Okay, if you consider the distance, okay, from this diagram, you can see obviously, yes, distance AB is longer than distance CD if they ask you about distance. Okay, distance AB longer than distance CD. CD is shorter. Okay, second, the planet is moving at a higher linear speed from A to B. Okay, this is another information we can get from this drawing. First, the distance, you can see clearly AB longer than CD. Okay, then the planet is moving at higher linear speed from A to B than from C 2D. Okay, how to understand this? You remember in the first chapter, we learned about speed. Okay, how to determine speed? Yes, very good. Speed is determined distance divide time. Okay, distance divide time. Okay, let's say if here, okay, we give an example. Let's say if the distance here is 100 meter. From A to B is 100 meter. Remember the time is the same. A to B and C to D has the same time. Let's say 10 second. Okay, let's say 10 second. So, and AB, let's say, is 100 meter. So can you tell me what is the linear speed of the planet from A to B? Okay, what is the linear speed of the planet from A to B if the distance of A to B is 100 meter and the time is 10 seconds? Okay, so how to calculate? Very simple. So remember, this is the formula for distance. Okay, we have D. We have speed, we have speed. Speed is distance divide time. Okay, remember speed is distance divide time. So from A to B, as I mentioned, the distance is 100 meter, example. Okay, and the time is 10 seconds. Okay, so from here, we understand the linear speed of this planet at AB is 10 meter per second. Okay, 10 meter per second. Okay, now let's say we give here. Let's say CD, the distance is 50 meter. Okay, so 50 meter is the distance from CD. And the time is the same. Okay, the time is the same, 10 seconds. Alright. Okay, so by this, you can see that when the planet move from C to D, it move with a linear speed of 5 meter per second. Okay, so from here, student, we understand when the planet is closer to the sun, it moves at higher linear speed. Okay, and when the planet is further from the sun at CD, it moves at a lower linear speed. Okay, I hope you are clear with that, how to understand a linear speed of a planet. When it is closest to the sun, it will be the highest, and when it's furthest to the sun, its linear speed will be the lowest from the example I gave you here. Okay, so are you clear with this example? For those who are clear, you can type 2 on how to understand why the linear speed is different when the planet is closest or furthest to the sun. Okay, if you understand, can type 2. Type number 2 on the live chat. Okay, thank you, Jimmy. Always be the first one to respond. Very good. All right. Okay, next student. Okay, now this is the third law, Kepler's third law. So Kepler first law talk about orbit, law of orbit. And Kepler's second law talk about area, law of area. Okay, what about Kepler's third law? Kepler's third law talk about or relate about the orbital period and the orbital radius of a planet. All right, so what does Kepler's third law define or state? Okay, so if you look from your textbook, Kepler third law say that the square of orbital period of any planet is directly proportional to the cube of the radius of its orbit. Okay, so it relates from this equation. So we call Kepler's third law as law of period. Okay, the square of orbital period of any planet, so this is the square of orbital period, t squared, okay, is directly proportional to the cube. Cube is power of 3, okay, of the radius of it, of the multiply 3 times. All right, okay, so this is the relationship, t squared directly proportional to r cubed, where t is the orbital period and r is the radius of orbit. T orbital period and r is orbital radius or radius of orbit. Okay, next. Okay, if you compare, this is all the planets we have in the solar system. Pluto has been taken out. Now we have 8 left. We have Mars, we have Earth there, Venus, Mercury, Jupiter, Saturn, Uranus, and Neptune. You can find this diagram in your textbook as well. Okay, so all these planets have their own orbit. Okay, all these planets orbiting Sun at their own orbit. So at their own orbital radius and at their own orbital period. So if you can see from this, what can we conclude? Okay, a planet which orbits with a larger radius has a longer orbital period. Can you tell me from this diagram which planet has the larger or the longest orbital radius? Definitely the planet must be the furthest from the solar system, the furthest from the sun. Which planet is that? The furthest from the sun, as you can see from this diagram. Definitely it will be the blue planet there, Neptune. Okay, Neptune at the longest orbit. So it has the longest orbital period. It need to complete one complete rotation orbiting the sun for each 164.8 years. Okay, the orbital period for Neptune is 164.8. Mean it require 164.8 years to make one complete orbit around the sun. Yes, Jimmy, the answer is Neptune. What about the planet which has the shortest orbital period? So for that, you must find the planet which is the closest to the sun with a shortest orbital radius. So that will be definitely Mercury. Mercury is the planet which is closest to the sun, where it only requires 0.2 years. 0.2 years to complete, okay, to orbiting the sun at one complete rotation. Alright. Okay, so for Venus itu 0.6 year, 1 year for Earth equivalent to 365 days, 1.9 years for Mars, 11.9 for Jupiter, 29.5 years for Saturn, and 84 years for Uranus. Alright, interesting, right? Okay, yes, very good. Mercury Hg. Yeah, we apply that in chemistry. Yeah, Mercury. Thank you, Jimmy. Alright. Okay, student. So, the first learning standard is done. Okay, to understand Kepler first law, Kepler second law, and Kepler's third law. Actually, if you follow me in my channel, I have composed one simple song to memorize Kepler's third law. I call it as the Lula Loop song. Okay, have you ever heard that song? If you follow my lesson, if you watch videos, PDPC videos on 3.2 in my channel, I think you're familiar with the song Lula Loop song. Lula Loop, Lula Loop, Lula la 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 Lula Loop. Okay, Lu, the first one is for law of orbit, Kepler first law, La, law of area, and Loop, law of period. So it complete Kepler first, Kepler second, Kepler third law, the Lula Loop song. Alright. Okay, and now student, let us move to the second learning standard. So I hope you are doing fine. You're doing fine there. Alright. So the second learning standard, how to express Kepler's third law. Okay, later we will apply this equation to solve a few problems related to Kepler's third law. Okay, relating the orbital period and orbital radius. So just now we understand T squared directly proportional to R cubed. Okay. So how to formulate Kepler's third law? So this is what we understand earlier. Ini yang kita faham sebelum ini. Yeah, Jimmy. It's like the lullaby song. Okay, Lula Loop. Okay, then planet makes circular motion around the sun. And Kepler's third law can be formulated by using our knowledge on Newton's universal law of gravitation and the concept of circular motion. Alright? Okay, student. Okay, then we can equalize these two equations. Okay, if you remember, the equation on the left is the equation for centripetal force. Okay, centripetal force is a force acting on an object which is moved in circular motion. Okay, where the direction of the force is always towards the center. All right. So this is the formula for centripetal force, mv squared divide r. And on the right is the formula for the gravitational force between the sun and any planet. The universal Newton universal law of gravitation formula, G m1 m2 divide r squared. So if we cancel the common factor on both sides, for example, we cancel the small m. M is the mass of a planet. Capital M is the mass of a sun. Okay, G is a constant. Then we can cancel off r, the radius r here, and cancel one r there, r squared. So what left? We have v squared left on the left side, and we have gm over r left on the right side. Okay. So earlier we understand linear speed also can be calculated from this circumference 2 pi r divide t. Okay, linear speed. 2 pi r is the distance on the sector. Okay, 2 pi r, and t is the orbital period. Okay, so we replace v in terms of this. So v squared become 4 pi squared r squared divide t squared. Okay, this one you square this. So it become 4 pi squared r squared divide t squared. So equal to gm over r. Okay, then how to make T2 as the subject? Okay, how to make T2 as the subject? So we rearrange this formula. So now it becomes T squared equal 4 pi squared r cubed divide gm. Alright? Okay. Then, for these students, 4 pi squared over gm, it's a constant. Okay, it's a constant, so we can replace it with constant k. Okay, then now we get t squared equal k r cubed. So this represents Kepler's third law formula, where k is a constant. Okay, later we will see a question how to apply this equation. Okay, so that is the second learning standard, how to formulate Kepler's third law equation. Alright, okay, now let us practice how to apply the equation we formulated earlier in the third learning standard. Alright, okay. So are you ready to do these exercises? Okay, let's move with me. Okay, so this is the formula we generated just now. T squared equal to 4 pi squared r cubed divide gm. Okay, so if we look at this diagram, we have a sun, okay, at the center of this solar system, and we have two planets there. Okay, you can see the first planet is Earth, okay, and second planet we have Mars with their respective orbital radius and orbital period. Okay, Earth have orbital radius of r1 and orbital period of t1. For Mars, it has orbital radius of r2 and orbital period of t2. Okay, actually we can find r1 or t1, r2 or t2 by applying Kepler's third law equation. Okay, so how to come out with this equation? Actually, this equation is given in the formula list in paper 1 and paper 2, so you don't have to worry, you don't have to memorize them, but you have to understand where and when to use them. All right, okay, so when we compare Earth and Mars in this diagram, so okay, number 1, this is for Earth, okay, and this is for Mars. So we equalize the first equation and the second equation. So since 4 pi squared over gm is a constant, so we can cancel them off. So what we have left is t1 squared over r1 cubed. This is for Earth, okay, on the left side, and this is for Mars on the right side, equal to the t2 squared divide R2 cube. Actually, it can be any side. Okay, if you want to put Mars here, Earth on the right, also no problem. It will be just the same. Alright? Okay, so now let us practice how to apply this formula. So it is better if you have calculator with you now. Calculator. Boleh ambil calculator, kita kira bersama-sama. Okay, so this is our diagram. So this figure shows you the planet Earth and Mars orbiting the Sun. Okay, the radius of orbit of the Earth is given 1.5 times 10 power of 11 meter. Orbital period of the Earth and Mars is 1 year and 1.88 years respectively. So you are given with 3 information there. Then you have to find the radius of orbit of Mars. Okay, so how to do this? Okay, so they give you for Earth, orbital radius is R1, orbital period is T1, and for Mars, orbital radius is R2, so we are looking for R2. Okay, and T2 is given 1.88 years. Okay, for Earth is 1, and for Mars 1.88 years. Okay, so what do you need to do? Just substitute the value for T1, R1, and T2 in the formula. So we can find R2 in the end. Okay, so this is all the formula given. R1, orbital radius for Earth. T1, orbital period for Earth. T2, orbital period for Mars. And R2, we are looking for orbital radius of Mars. Okay, so can you find them, student? I give you a few seconds for you to deal with this question. Okay, if you are done, you can share your answer in the live chat. Okay. Okay, so this is the respective formula you can apply. Just put them in the correct order. For T1, R1, this is T2, so we are looking for R2. Okay, so I'm waiting for your answer. Anybody, if you are done, you can share your answer in the live chat. Okay, so for those who are just joining us, now we are doing the first exercises on how to apply Kepler's third law formula in finding the orbital radius of Mars planet. Okay, I hope you're doing good there. Okay. So this is the substitution that we made, and that is the final answer. Did you get the same answer with me, students? Okay, so this is the substitution, T1 for Earth, and this is R1 for Earth. Okay, please be careful when you do the calculation. Never miss the square and the cube. Okay, so R2 we are looking. So we rearrange, making R2 as the subject. So to find R2, you have to find the cubic root for this calculation. All right. Okay, who get the same answer with me? Type 3 in the live chat there. So the orbital radius for Mars is 2.285 times 10 power of 11 meter. Okay, I advise you to put your answer in 3 or 4 decimal places. Yes, congratulations, Jimmy, to have the same answer with teacher. All right. Okay, what about the rest? Can you solve this problem? You also have Mr. Pei there. Good evening, Mr. Pei. Thank you for drop by. Okay, terima kasih support kelas kita malam ini. Okay, Jimmy, say hi to Mr. Pei. prepare as well. Alright, okay, next student, tengok soalan yang seterusnya. Okay, the second example. Okay, now you are given this figure. We have Earth now. There is a moon and satellite orbiting the Earth. Okay, moon is a natural satellite. Okay, moon orbiting Earth. Satellite 1 also orbiting the Earth. Okay, for satellite 1, the orbital radius is R1. Okay, and for the moon, the orbital radius is R2. Okay, if you look from this arrow. Okay, and H1 is the height of satellite 1 from the surface of Earth. Okay, H1 is the height of satellite 1 from the surface of Earth, and H2 is the height of the moon from the surface of the Earth. Okay, so please don't get confused. What is R1, what is R2, H1 and H2. R1 refer to the radius, and H1, H2 refer to the height of satellite 1 and the moon from the surface of the Earth respectively. Okay, R1 is the distance from the center of the Earth to the center of the satellite. So we call it as the orbital radius. Okay. And R2 is the distance from the center of the Earth to the center of the moon, called as orbital radius of the moon. Okay, so here, what are we looking for? Refer back to the question. They ask you to find the orbital period of the satellite. They find the orbital period of the satellite. They give you this information. This is a research satellite, need to orbit at this height, 390 kilometer, to capture clear image of the surface of the Earth. So they give you the height here, 360 kilometers. So H1 is 360 kilometer. Alright. So the question asks you, what is the orbital period of the satellite? Radius of orbit of the moon is given. Also the orbital period of the moon, 655.2 hours. Alright. Okay. So now how to work on this is the information you are given. Okay, students. So what is R1? R1 is orbital radius of satellite 1. Okay, so how to find orbital radius? This is the radius of Earth. Okay, radius of Earth plus the height of satellite from the Earth surface. So we will have the orbital radius of 6.76 times 10 power of 6 meter. Okay, this is what you must understand. How to find orbital radius by find the sum of the radius of Earth plus the height of planet from the surface. And R2, this is the orbital radius of Sun. This is the orbital period of Sun. So we want to find now T1, orbital period for satellite 1. Okay, for the time here could be in years, it could be in hours, it could be in days, it could be in seconds. So it doesn't have to be in second. Okay, that's not necessary to be converted into second. It can be in different units. Okay. Okay. So here given hours. So now the orbital period for both planet in hours. Alright. Okay. So this is the formula for Kepler's third law. T1 squared over R1 cube equal to T2 squared over R2 cube. Okay. On the left, refer to the satellite. Satellite is labeled as 1. On the right refers to the moon, since the moon is labeled as 2. Alright. Okay, so the substitution. So we substitute. Okay, so now we are looking for T1, orbital period for satellite. Okay, so this is the rest. Okay, the value for the rest, R1, T2, and R2. Again, please be aware with the square and cube, okay, in both sides. So if you calculate, so T1 squared equal to this. So to find T1, you have to square root, okay, these numbers on the right. So it will be equal to 1.534 hours. Okay, did you get the same answer with me, student? If you do, you can type 4 on the live chat. Okay. Type 4, if you get 1.536 hours as the answer, orbital period of satellite 1. Okay. If you have any question, you can also type on the live chat. Siapa nak tanya soalan, boleh tanya pada live chat. I will try to respond to you as possible. Okay. Okay, I hope you're still doing good there. Okay, you can also screenshot the answer, then you can try them later on. Okay. So students, let us take a short break for a while. So please don't go back after this short commercial break. Okay. Okay, hello everyone and welcome back to the class. For those who are just joining us, I'm Cikgu Hasnitah from SMK Bagan Jaya, Butterworth, Pulau Pinang as your presenter for this evening. We are now discussing physics online, free online tuitions on the third chapter, gravitation, content standard 3.2 Kepler'S. Let's to do a few example of exercises, so question related to Kepler's law. So I hope you are ready to do these exercises. Let us do some practices from what you understand on what I delivered earlier. Okay, let us take a look at the first question first. It is a simple one. You are given a diagram. I believe maybe some of you used to see this question before. Okay, we have a diagram there. It shows orbit of planet Venus around the sun. So this is the sun. Okay, at the focus, okay, on the right side of this elliptical shape orbit, and Venus is orbiting the sun at this position now. So we have 3 points marked along this orbit: position X, position Y, and position Z. 3 position. Okay, the question is, compare the linear speed of planet Venus at position X, Y, and Z. Okay, how to make comparison. Just now I discussed with you, if the planet is closest to the sun at the perigee position, we call it the perigee position. So it will be, the linear speed will be at the highest. And when the position of the planet is the furthest from the sun at an apogee position, so it will be, the linear speed will be at the lowest. So how to compare? So you can use the comparison symbol in mathematics, greater than or lower than. So how to arrange X, Y, and Z? Okay, arrange them in how to arrange? Okay, you can arrange in ascending order or descending order because it doesn't mention here. So which one is the highest linear speed? Okay, highest linear speed is Y, followed by X, followed by Z. So you can write at Y, it is greater than at X, greater than at Z. Mean the linear speed is the highest at Y and lowest at Z. Alright, yeah, very good, Jimmy. X, Y, Z. Okay, yes. Next. Okay, next question 2. Okay, now again they give you a diagram. Now the sun is at the left focus of the elliptical orbit. We have 4 positions there, A, B, C, and D. Okay, a planet is orbiting the sun in this direction. So the question is, at which position is the planet moving at the lowest orbital speed? Again, to deal with the speed, student. Is it at A? Is it at B, at C, or at D? The keyword is lowest orbital speed. So, lowest orbital speed. Definitely, Jimmy say B. What about the rest of you? What do you say? Okay. The answer, yes, answer is at B. Okay, when it is furthest from the sun, the planet will have the lowest orbital speed. Very good. Okay, then the third question. Okay, third question. You are given this diagram, a comet. Okay, a comet, and this is the position of the sun at the focus of this elliptical orbit. Okay, so what can you say about the orbital speed of the comet in this orbit? Is it constant? Is it decreases when closer to the sun, or is it increases when closer to the sun? Okay, which one is the correct answer, student? The orbital speed. Is it constant? Okay, all along, or is it decreases when closer to the sun, or increases when closer to the sun? Okay. Again, Jimmy says C. Okay, who else are still with us? What do you say? Is it A, B, or C? It's a simple question, right? Yeah, so the answer is none but C. The speed is increases when closer to the sun. All right. Okay, next. Okay, now you have to check which statement is correct about Kepler second law. Remember Kepler second law? Lu lalu la, law of area. All right. Okay, which one? Okay, the first one, A, the orbit of a planet around the sun is an ellipse with the sun is at one focus. This one refer to? Yes, very good. This one refer to Kepler's first law. Okay, what about B? The square of the orbital period directly proportional to the cube of the planet average distance. So this is Kepler's third law, law of orbit. So the answer must be yes, C. A line drawn from a planet to the sun sweeps over equal area in equal time. So law of area. The keyword there is area. So answer is C. Yeah, great. Thank you, Jimmy. Good. Okay, next student. Question 4. Okay, so this is now we are moving to the structure question, and this is the last question for tonight. Okay, I took this from last year SPM trial paper. All right, but I didn't remember from which date I took. Okay, sorry for that, but never mind. Let us take a look at the question. Okay, you are given diagram 5.1. Okay, it shows a planet. This is the planet. Okay, evolve the sun or orbiting the sun. Time taken for the planet to travel from A to B is equal from C to D. So we understand this from the lesson earlier. Okay. So this is the sector made AFB, and this is the sector made at CFD. All right. Okay. So the question asks you to state Kepler's second law. Okay. If they ask you another question, maybe they will ask you which state the law relate to diagram 5.1. Okay. So the answer will be Kepler's second law. But here they already tell you the law. They want you to state Kepler's second law. So do you remember how to write Kepler's second law? Yes, Jimmy, this is law of area. Okay, law of area. So what do you remember? Okay, so Kepler's second law say that a line that connect a planet to the sun sweeps out equal area in equal time. Garis yang menyambungkan planet dan matahari akan mencakupi luas yang sama dalam selang masa yang sama apabila planet bergerak dalam orbitnya. Alright, okay, Kepler's second law, law of area. Okay, next. Okay, now you have to make comparison. Okay, based on diagram given, make a comparison on the length of arc of AB and CD. So compare the length of arc AB and CD. Which one longer? Which one shorter? You have to check from the drawing earlier. I showed you the drawing earlier. This is AB. So obviously you can see AB is longer than CD, right? Okay, so we say the arc length of AB greater than CD. So this is what we want to see. Kita nak tengok yang ini. AB greater than CD. Okay, or you can answer in word AB longer. Okay, or CD shorter. AB longer than CD. Okay, next. Okay, the second comparison, you have to compare the area covered by the planet region, AFB and CFD. Okay, what can you say about the area covered of the region AFB and CFD? Are they the same or are they different? If you understand Kepler's second law, you must know the answer. Yeah, Jimmy say same. Okay, same. So same, 1 mark if you say same. Okay. Or if you want to write in full sentence, no problem. D, okay, sorry for the wrong spelling there. The area covered by region AFD equal to CFD. This one AFB, sorry. It should be AFB. Okay, this one should be AFB. Okay, equal to CFD. Okay, is it AFB? Okay, we look at the diagram first. This one AFB, this one CFD. Okay. So this one AFB, this one CFD, this one B. Okay. Alright. Okay, so you just write same. Okay, same or equal. Okay. Then what about the linear speed? Linear speed A to B and C to D. So from the diagram, you can see A to B is closest to the sun and C to D is furthest to the sun. So we understand the linear speed as AB is, don't say faster, Jimmy. Okay, this is another thing. Okay, when we talk about linear speed, it is better for you to just compare them. Which one higher, which one lower, bigger or smaller. Okay, so we say the linear speed of A to B is greater than or higher than from C to D. Okay, because I'm afraid in sometimes the word faster or the word slower is not acceptable. Okay, so it's better to write higher or lower, bigger, smaller, larger, smaller. Okay, we use that terms when doing comparison. Okay, the linear speed from A to B higher than that to C to D. Alright? Okay, yes. Okay, next student. Okay, then C. State the relationship between the arc length and the linear speed covered at both region. Anything you can say from the relationship we write earlier? Nyatakan hubungan antara panjang lengkok dengan laju linear yang dicakupi. Okay, what can you say about the length of arc and the linear speed? Okay, in both. So you can see when the arc length increases, the linear speed increases. Okay, apabila panjang lengkok bertambah, laju linear bertambah. Okay, when the arc length increases, the linear speed increases. Okay, next, name the force that act on the planet when it is orbiting the sun as shown in diagram 5. Okay, how to respond to question C2? Come on, everyone. Name the force acting on the planet when it is orbiting the sun as shown in the diagram. Apa nama daya yang bertindak ke atas planet yang sedang mengorbit matahari seperti yang ditunjukkan dalam rajah 5.1. Yes. Actually, there are two acceptable answer. There ada dua jawapan yang boleh diterima di sana. Okay, G-force. What is G-force? Gravitational force. Right in full, Jimmy. Also known as what? The force acting on an object moving in circle. What is the name of that force, student? The first one, you can say yes, gravitational force. Another one, it can be called as centripetal force. Okay. At this moment, the gravitational force is equal to the centripetal force. Okay, so it either gravitational force or centripetal force. Alright, okay. Okay, so this one you have to mark, student. For question D, you have to mark the direction of linear speed in diagram 5.2. Okay, this is the position of the satellite which is orbiting the Earth. Can you mark the direction of the linear speed? Okay, how to mark? Remember, the direction of the linear speed will be tangent. Okay, will be tangent to the orbit line. Okay, so you can find a ruler and draw one line tangent. So it can be in this direction. Okay, tangent 90 degree to the orbiting line, or it can be in this direction. Okay, here. This is also a tangent line 90 degree. So this is the direction of the linear speed. You draw either at this direction or at this direction. All right. Okay. Next. Okay, next question. Okay, this one you have to do some calculation. Okay, so you are given the satellite. It say the satellite has reached outer space and orbiting the Earth at this altitude 2.0. How to read this? Megameter. Mega means power of 6, 10 power of 6. So you have to find the linear speed of the satellite when it is orbiting the Earth. Okay? So you are given the Earth mass as well and the Earth radius, 6.37 times 10 6 meter. Okay, how to find? Okay, so this is the formula for linear speed we learned earlier in the first content standard. Alright, V equal to the square root of gm divide r. Okay, this equation again is given in the formula list in paper 1 and paper 2. Yes, good Jimmy. A very good reminder. Okay, the orbital radius must plus the altitude. Altitude means the height of the satellite from the surface. So must plus with the radius of Earth. See, as shown here. Okay, sorry, here the power, this should be 10.6. Okay, this should be 10.6. Okay, this one should be 10.6. Okay, this one also should be 10.6. Okay, okay. So this is okay, Earth gravitational. This one supposed to be negative 11 up there. Constant, gravitational constant, and this is the mass of Earth. This is power of 24 up here. Okay. Okay, then you can calculate now. So this is for the orbital radius, 6.37 times 10.6 plus with the altitude 2 times 10 power of 6 from here, megameter. Alright, okay. So now can you find the answer? Don't forget to square root everything. Okay. So if you do, you can share your answer before showing mine. Okay. Just press your calculator and solve for this equation. So I will share to you the link for the ECDL Express a short while. So you please don't go away yet after you are done with this exercise. So I think this is the last question for tonight. Okay. So what is your answer, students? Okay, as for mine, I get, okay, so this is the answer, 6,897.4308 meter per second, or in standard notation, you can write as 6.8974 times 10 to the power of 3. Sorry, again, this is power of 3 meter per second. Okay. Who get the same answer with mine? Type number 5. As in maroon 5. 5. Okay. Again, you can place your answer at 3 or 4 decimal places. Alright. Okay, very good. Yes, thank you very much, Jimmy. Okay, for getting same answer with me. Okay, so student, I guess that's all for tonight. Alhamdulillah. Lesson on 3.2 Kepler'S law. So students, this is a token of appreciation for you. So you can click on this link and type in your name and your IC number accurately. So you will receive the e-cert. Okay, it will be sent to your email in a short link. Okay, jadi terima kasih banyak-banyak kepada yang mengikuti kelas pada malam ini. So cikgu harap kelas ini membantu anda untuk memahami tajuk ini dengan lebih baik. So I hope those who are following this lesson can benefit, okay, more or less from what we are discussing just now from the 8:15 until now 9:28. Alright. So jangan lupa bersama-sama dengan kami lagi. Minggu depan Mr. P akan kembali bersama anda dengan tajuk seterusnya 3.3 Man-made satellite. Okay, the final topic on chapter 3 before we move to the new chapter 4 heat. Dan untuk minggu depan juga jangan lupa bersama-sama dengan kelas tingkatan 5 akan diteruskan oleh teacher Slinda dengan tajuknya 3.2 rintangan. Bab 3, elektrik tingkatan 5, Jumaat 9.30 malam dan bersama dengan Mr. P pada hari Ahad 8.15 malam for 3.3 man-made satellite. Okay, again, thank you very much for joining us. I really appreciate the time and effort you made. So we always pray that you always excel in physics. Saya Cikgu Hasnitah bersama-sama dengan cikgu-cikgu lain di Panitia Fizik Akademi Youtuber sentiasa mendoakan anda menjadi pelajar yang cemerlang, selain daripada itu menjadi anak yang baik kepada ibu dan ayah, yang hormat guru-guru di sekolah dan menjadi aset yang berguna kepada negara kita Malaysia di satu hari nanti. Jadi teruskan belajar dan teruskan dengan adab dan nilai-nilai yang murni. Jadilah manusia yang sentiasa memberi sesuatu yang baik kepada masyarakat di sekitar anda. Okey, itu saja untuk malam ini. Sedikit nasihat pada cikgu. Jaga diri. InsyaAllah kita jumpa lagi dalam masa yang akan datang. Semoga anda semua sentiasa berada dalam keadaan yang sihat dan sejahtera. Jaga diri, jaga kesihatan fizikal, jaga juga kesihatan mental anda. Okey, semoga kita sama-sama menjadi manusia yang sukses dan berguna kepada agama, bangsa dan masyarakat. Jadi, cikgu sudahi dengan wabillahi taufiq wal hidayah. Sesungguhnya yang baik daripada Allah, yang kurang itu semua daripada kedangkalan dan kelemahan cikgu. Jadi kita jumpa lagi dalam kelas yang akan datang. Assalamualaikum. Bye-bye semua. Selamat malam dan selamat berehat. Okey. Assalamualaikum. Bye.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.akademiyoutuber.com. Berusaha ayu capai kecemerlangan, berpadu ayu cipta kegemilangan, bersatu ayu bina wadah terbilang, terus berjaya bersama ayu.
Berusaha ayu capai kecemerlangan, berpadu ayu cipta kegemilangan, bersatu ayu bina wadah terbilang, terus berjaya bersama ayu.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru ayu, mencapai misi yang satu. Bervisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. Mara semua para ilmuwan, semai